Hello everyone. So we are discussing basic system properties. In the previous video we have seen the system with and without memory, and we have also seen some examples to understand this topic. Now we will move on to the second property, which is invertibility and inverse system. So we will first define what is an invertibility means. So a system is said to be invertible if distinct input leads to distinct output. So this is the definition, and a different way to understand invertibility is also that if we cascade a system, so this is suppose a system and this is the inverse of the system. So suppose s to the power minus 1 represents the inverse of the system, and if we cascade these two back to back, so the output will be same as input. So let's see some example to understand it better. So suppose we have taken a signal as yt is equals to 2 of xt. So the relationship between input signal and output signal is depicted by this system. So this system is invertible, and the inverse system is given by wt, which is equals to 1 by 2 of y of t. So suppose again we'll see that cascading property. So if yt is our 2 of xt and we cascade it with its invertible system, that is wt, which is represented by 1 by 2 y of t, then the output will be x of t. So this is the property of invertible system. A similar example for invertible system is accumulator. So suppose we have a system of accumulator yn is equals to summation k is equals to minus infinity to n x of k. So the invertible system of this system is represented by w of n, which is equals to y of n minus y of n minus 1. And if we cascade these two systems, we will get the input. So these are few examples of invertible systems. Are there examples of non-invertible system exist? Yes. So the example for non-invertible systems can be yn is equals to 0. So there cannot be any other values. So here the distinct input cannot give distinct output. So for any input which is multiplied with 0 will give you 0 value. So there is no distinct input giving distinct output. That's why this system is said to be non-invertible. Similarly, a system described by x square t can also be a non-invertible system, because here if we take some positive value of xt or negative value of xt, both will lead to the same output. So distinct input will not lead to the distinct output. That's why both of these examples are for non-invertible system.